Hey, this is Zach from ZachMakesGames.com. Wanted to show off another project I did in OpenGL. This was the second project I did in my OpenGL class, and this project was all about teaching us the importance of order when doing rotations and transformations. So as you can see, we have a helicopter with spinning blades on it. And the deal was, it can be tricky when you first start working with graphics. The order of operations really matters, especially when you're doing matrix transformations. Um, in this particular program, we weren't doing our own matrix transformations, but OpenGL, the translate and the rotate functions and the scale functions do matrix operations under the hood, and it was very important for us to realize that and try to understand that the order is important, that matrices are not commutative in their operations. Prior to taking this class, I had actually taken a class called CS 491, which was, uh, can't remember the title of it, but it was all about special techniques in games, special things that was really about peeking under the hood of engines and seeing the glue that really kind of held games together. And one of the things we really hammered on in that class before I took CS 450 was matrix operations, and the order is important. So I actually came into this with a little bit better understanding than the rest of the class. Um, because what we did in that class is we had explored the order of matrix operations. We had done some projects where we were doing multiple things being rendered with matrices, and we could see that the order really mattered. But this is fairly simple. At this point, we still were not using vertex buffers. We were still doing the old vertex lists method and calling the list to display things. We were also using the GL color and GL translate instead of doing our own matrix transformations, and pushing those to the GPU. But here's what I came up with. It was pretty easy, especially having the prior knowledge of the matrices beforehand. So I can't recall which way the rotors start. I believe they start in a different position, but the goal was to every frame rotate them so they looked like they were moving, and then put them in the right place. So getting them in the right place was really, really important. And here's what I ended up doing. So the body of the helicopter was drawn with this list right here, and then um, I put it into place. I also drew that blue torus. That was just kind of a target so that the instructor could see things were looking the right way. Um, and then I would save the matrix, and then I change the color back to white, and then here we go. So the deal with matrices is when you're programming them, the order that you call them seems to happen backwards. And it makes sense when you start thinking about the order that matrices do math. So if you're doing, I wish I had a whiteboard here. If I had so let's say I had um, matrix A times matrix B times matrix C equals matrix D. That's a typical way to a typical matrix multiplication operation, right? So this would be your outcome, so we can get rid of that and just think of it as A, B, and C right now. So they happen backwards, right? So matrix B seems to take matrix C takes place first, and then matrix B, and then matrix A. And I'm not entirely sure why that is, um, but from a programming point of view, it makes sense to me in that you're calling matrix A here. then you're calling matrix B here, and then you're calling matrix C here. It's happening in the same order that this would happen, which is why it happens backwards. And I will admit that I need to do a little bit more studying on matrix operations to understand why matrix operations seem to work backwards. But anyways, here's what I did. So I would move the rotor, and I should have made a note. Okay, so this seems to be the smaller one. It's got the smaller scale on it. This is the bigger one with the bigger scale on it. So I did the top rotor first. So what I did was I moved it up by 2.9 and back by -2. So I would place it where it's supposed to be. Then I would rotate it by its rotation. That's where in the rotation it is. And then I rotated it 90 degrees to get it in the right plane along the XY plane, the XZ plane. Then for the rear rotor, I would move it back to where it needed to be. I would change its rotation, and then I rotated it 90 degrees along a different axis. And I can't recall offhand which axis is which. So the main rotor I rotated along the x-axis, and then the tail rotor I rotated along the y-axis. And it came out well. I think I got this pretty close on the first shot because I had that kind of presumption of how the matrices worked. I do recall having to fumble. They were being tilted in a weird way. I was having trouble with the axes. I think I was reading them wrong. I was thinking they would rotate in a different way. It's easy to misconceive rotating around the axis rather than it. Yeah, it was just confusing at first, and I've done a lot more since then too. So the rotation and everything is it makes a lot more sense. I can just kind of see it. Can also go into orthographic view, which is quite strange to see, but it's kind of cool. And that's really we were just using the OpenGL perspective or ortho call when we were setting up the camera, so that wasn't really a big deal. And I can also look inside the cockpit too. That was one of the things why we had this targeting ring. He wanted us to be able to peek inside the helicopter, and that was kind of fun. This was a fun project and actually ended up inspiring me in another project that I will get to in a later video, so watch for that one. Thanks for watching.